Dear children, so in this video we'll discuss how the genotype of a given pedigree chart can be understood, and same way we'll see how the probability of the given genotype can also be found out. So you know that for practicals you have to learn only about the color blindness, right? So only that disease we are going to learn. So let us see how the genotype of that particular disease can be understood using a pedigree chart. So for your practicals tomorrow, you will just see the pedigree chart kept there without the genotypes of any of the generation, right? So you will see in this diagram you can see the parental generation is there, F1 generation is there, F2 generation is there, and in your exam also you will see the same type of pedigree chart, but they won't give you the name where the parental generation is, which is the first generation, which is the second generation. These informations will not be given, and genotypes also will not be given. So what you have to find out is you have to understand what the possible genotype of that particular individual will be. So that is what you have to find out. So question will be like that. They will ask you to find out any of the genotype of a given pedigree chart. For this, first we have to understand the letters which we have to use when we denote about a particular disease, and before that you should know what type of disease is it. So we are studying only about the color blindness, and this color blindness, it is a sex-linked recessive disease. Okay, and why do we call it as a recessive disease? Because in this diagram you can see we know that if the trait is dominant, then any one of the parent should have been affected by disease. You can see it here, but here none of the parent is affected by the disease, right? So it is a recessive trait. And how do we understand that it is an X-linked or sex-linked disorder? Disease. It is with the help of the male and female's disease occurrence, and if male and female have equal chance of disease in a particular pedigree chart, then it is an autosomal trait. And if the given pedigree chart has most of the males affected, only the males affected, then we can say it is an X-linked disease. So we can see it here. Here only males have been affected, so we can understand that it is a X-linked disease. Clear? So now let us see how to find out the genotypes. So as I told you, for the case of autosomal diseases, we have to use capital A, then capital A, small a, then you have to use small a. Okay, now we know that we understood it is an X-linked recessive disorder, right? So it is an X-linked recessive disorder. So in that case, what should we do? We have to use X and X for the females, and we have to use X and Y for the male. I hope you remember that, right? So if it is a male individual, then the genotype should be X and Y, because they have an imperfect pair of chromosome. They have X and Y chromosome, and females, they have a genotype of X and X. Clear? So these are the letters which is used to denote the male and the female individuals. And if the individual is deceased, if it is a deceased male, then we should write as XCY, because males have only one X chromosome. And we know that if one X is being transferred to an individual, and that particular individual who is a male will be affected by the color blindness, because what is the reason? Males do not have an perfect pair, that is XX is not present in males. And the father, if it is a deceased one, if he has the color blindness in his X chromosome, then surely his male children will have the disease, because males will have X and Y, right? And this X, if it comes from mother, it's okay, but if it comes from father, surely that particular child, that particular male child will be affected by disease. And in case of females, if a female is a carrier, which means that they will not have the disease, but they will carry the genes which causes the disease. So we will represent it by XCX. Okay, and if a female is deceased, think that the person is deceased, then she will be XC and XC. Understood it? Clear, children? So we will now use only 3 of this in finding the genotype, right? It should be either XY or it should be XCY, which means father is a deceased person, and then if you take the case of female, it should be XCX, or she can be XX without disease, or she cannot be carrier. And in some cases, the women, if she is deceased, it will be XC and XC. But usually, understand that females have very lesser chance of transmitting they cannot pass the disease to their female child. Okay, mothers cannot pass this X-linked disease to a female child. The chances are very less. Clear, children? So let us now work out the genotype of the given pedigree chart. Okay. So now let's see how to find out the genotype. So the first thing which you have to do is, when you see a pedigree chart and when you find the shaded portions in the pedigree chart, then you have to find whether it is male or female. So for males, we know that we use a square box in case of males, and for females we use a circle. So when the square box is shaded completely, then the male is affected by color blindness. So here you can see the 2 male childs which are affected by color blindness. Okay, so surely their genotype will be XCY, because they are deceased person, so they will be X, C and Y, right? So if one of the X is having the particular disease causing gene in it, there is color blindness causing gene in it, then surely the male child will be deceased, because it is an X-linked disease. It is not a Y-linked disease, right? അപ്പോൾ Yയിൽ ഉണ്ടാവണം ആ ജീൻസ് ഉണ്ടാവണം എന്ന് ആവശ്യമില്ല. Xയിൽ ഉണ്ടായാൽ തന്നെ ഷുവർ ആയിട്ട് that male child will be a deceased person. Clear? So if we have to first write the genotype of these 2 individuals, it will be XCY. Now, if this child has to be, if the fifth person in this pedigree chart, if he has to be deceased, then surely one of his parents should be a carrier. Okay, only then this disease can be transmitted to the next generation. So see this parental generation, I'm just writing it as P. See this parental generation. അപ്പോൾ ആദ്യം എന്ത് ചെയ്യണം, നമ്മൾ ഡിസീസ്ഡ് ഇൻഡിവിജ്വലിൻ്റെ ജീനോടൈപ്പ് എഴുതുക. Okay, and if you get the deceased individual's genotype, using that we have to find out the genotype of the parents. How will you find the genotype of the parents? We know that if the male is deceased, then it should be again shaded with red color. അപ്പോൾ എന്തായി, അപ്പോൾ അവിടെ നമുക്ക് XC എന്ന് എഴുതാൻ പറ്റില്ല, because that person is not deceased. The father is not deceased. So if the child is deceased and if the father is not deceased, it means that he has a normal gene which is XY. You can see it here. I have written XY. And same way you can see if the mother is deceased, again she should be shaded like this. But in the diagram they don't give that. So what does that mean by the child is having the disease? You can see the mother's child is having the disease, but the mother is not affected by the disease. Then how should she be? She should be a carrier. It means that one of her X chromosome will be carrying the genes which codes for color blindness. Understood, children? Okay, understood it? Clear, right? So we have find out the genotypes of father and mother. So father should be XY and mother should be XCX, because she is a carrier. That is why she has passed the disease to the male child. Okay, so one of the male child's genotype we have understood, that is deceased person's genotype has been predicted by us. So it should be XCY. Now we have to predict the genotype of other offsprings also, or the other persons also from the same parent. ഈ ഫസ്റ്റ് പാരന്റൽ ജനറേഷന് ഉണ്ടായ എല്ലാ ഇൻഡിവിജ്വൽസിൻ്റെയും ജീനോടൈപ്സ് ആണ് നെക്സ്റ്റ് നമ്മൾ കണ്ടുപിടിക്കേണ്ടത്. So if we have to find the genotype of each of the other individuals in the F1 generation, then we have to see how their offsprings are. Okay, അപ്പോൾ ഇവിടെ നമ്മൾ ഓഫ്സ്പ്രിങ്സ് വെച്ചിട്ടാണ് പാരന്റൽ ജനറേഷൻ എങ്ങനെയായിരിക്കും എന്നുള്ളത് പ്രഡിക്റ്റ് ചെയ്തത്. സെയിം വേ ഹിയർ ഓൾസോ ഇഫ് യു ഹാവ് ടു ഫൈൻഡ് ദ തേർഡ് ആൻഡ് ഫോർത്ത് ജനറേഷൻസ് ജീനോടൈപ്പ്, ചെക്ക് ഫോർ their offsprings. So you can see it here, the offsprings here are normal, right? Both are male child and so they are normal. It means that the male children has not carried the X chromosome from their parents. അതൊരു മെയിൽ ചൈൽഡ് ആണ്. അപ്പോൾ ഏതെങ്കിലും ഒരു പാരൻറ്റിന് ഇഫ് ദേ ആർ ആക്ടിങ് ആസ് കാരിയർ, ഷുവർലി ദേ വിൽ ബി അഫക്റ്റഡ് ബൈ ദ ഡിസീസ്. Understood it? So if you take this case, children, the genotype of the father should be XY and the genotype of the mother should be X and X only. Sorry children, I have written C here. It should not be C because both the males are not affected. So it means that mother will not be a carrier. So it is XY and XX. Okay, and the fifth genotype we have founded it, and then the sixth one, you can see it is not a deceased male child, right? So you can see it here, this is not a deceased male child, so automatically the child will be XY. Okay, and then we have another female which has the same genotype like XX, or sometimes she might be XC also, right? And coming to the next one, so coming to the person number 8, here you can see the 8 has married a male and their male child is affected by a disease. Okay, so that male should be XCY because he is a deceased person, so his genotype should be XCY. Okay, and the other possible genotypes from these combinations will be X and XC, XX and XY, because here one of the parent is a carrier. How do we understand that one is a carrier? Because all the other children are not affected. 12 and 14 are not affected, but only the 13th child is affected. Okay, so if the 13th child is affected, then he would have got the XC from his mother. Okay, and why is it not from his father? Because if the father is XC, then surely he would have been suffering from color blindness, but we see that it is not shaded, so it means that his genotype is X and Y and the mother's genotype will be XC and X, right? So only due to the transmit of this XC to the male child we can understand he has become a deceased person. Okay, and the 12th person, she is not affected by disease, so she should be a carrier, right? And the 14th person, again she is not affected by the disease, so it should be X and X. Okay, because why am I saying X and X and why am I saying X and XC here? When you work out the Punnett square, so if I take XC and XX from mother and XY from father, if I take in this order, then the combination will be XCX, XX, then XCY, and we will get XY. Okay, so if one of the male child is affected, then one of the gamete will be like this. Now see, the other male child will not be affected by disease because it is normal X and Y. But you can see it here, if it is a female child, one will be a carrier and the other person will be a normal female. So here this person is a carrier and this one is a normal female child. Understood, children? So this is how we have to find the genotype of the given individual in the first or second generation or in the parental generation. So this is how we have to find out. Now let us understand how the probability can be found out. Right? So now I am taking a genotype which is XC, X in case of female, and XY in case of male. Or else if I take XC in case of male, what should happen? If I carry out this Punnett square, then what are the possible gametes which will be formed from this? It should be XC, XC, these two, and then this one and this one. So it should be X, XC, and then Y and this one, it should be XCY, and Y and this X. So it should be X and Y. So here from this Punnett square, if the parental generation has a genotype of XC, X and XY, then the offsprings will be of these particular combinations. Right? So they will be like, so what will be the possible genotypes from this parental generation? The possible genotypes will be XC, XC, and XCX, and then XCY and XY. So these two children are female and these two will be male. So this is how the gametes will segregate and pair. And if you take this case, 50% is female and the other 50% is male. Right? And in the 50%, the chances of a deceased female is 25%. Right? So the chances of a deceased female is 25% because she has both the X's which has C in it. Then she should be a deceased person. And if they ask you to write the percentage of carrier female, then you have to write again it will be 25%. Because the first female will be deceased, the second one will be carrier. She will not have color blindness, but she will carry a gene which codes for color blindness. Okay, so her alleles, when the pair of alleles, one of them will have a gene which codes for the color blindness. And if they ask you the question about the percentage of normal male child, then it will be again 25%. Okay, and if they ask you to find the deceased percentage of deceased male child, then again it will be 25%. So totally 50 plus 50 is 100%, and chances of a female to be deceased is 25%, chances of a female to be carrier is 25%, chances of a male affected by a disease is 25%, and the normal male will be 25%. So total 100% is what we obtain. So what is this 100%? It is nothing but about, it depends upon all the possible gametes which are formed from the parental combination. എന്തെല്ലാം പോസിബിൾ gametes ആയിരിക്കും ഉണ്ടാവാന്നാണ് നമ്മൾ ഈ Punnett square വെച്ചിട്ട് അണ്ടർസ്റ്റാൻഡ് ചെയ്യുന്നത്. Clear, children? Understood it? Okay, now so please change this alone in this female which is fourth generation. It should be X and X. Okay, the C should be erased. Please note that, children. I don't know, I did it little earlier, I didn't check with that. So please write it as X and X. It should be X and X and not XC and X, because the male child, if we do a Punnett square, it will be like XY, then XX. So this X and this X, again X and Y, then X and X, then again X and Y. So both the males are not deceased in this condition. Okay, so that is why the female should not be a carrier. Understood, children? So go through this properly. So based on this only you will get question. Okay, if you have doubts you can WhatsApp me, children. Om Namah Shivaya. Thank you.